This is going to be a binomial hypothesis test, one-tailed with a critical region. Okay, so the first thing we do is we read the question and try and turn the words into some maths. So we have got a pharmaceutical company is developing a new drug to treat a certain disease, and the company will continue to develop the drug if the proportion P of those who have the disease and show a substantial improvement after treatment is greater than 0.7. So the proportion P has to be greater than 0.7 for them to continue. The company carries out a test at the 5% significance level on a random sample of, the data is going to be 14 patients who suffer from the disease. So we have to find the critical region for the test. That means we carry out the test up to the point where we would find the probability, and instead we find the critical region. So starting with the hypotheses, we need a null hypothesis where P is equal to something. So the only thing shouting out here is P is going to be the proportion of those who have the disease and show substantial improvement, and P is equal to 0.7. So that's our null hypothesis. Our alternative is the thing we're really interested in, and that is that P is actually greater than 0.7. So P is the proportion who have the disease and show substantial improvement after treatment. Words from the question, in fact P from the question. Now we look at where our data is. So our data is going to be 14 patients. So we're going to take those and we're going to count the number of people who have show a substantial improvement after treatment. Okay, so we define an X here. There we go. And then we can write the distribution for the number of patients who've made substantial improvement. So that would be a binomial where substantial improvement is a success. We have 14 patients, so that's 14 trials, and the chance of making substantial improvement is 0.7. Okay. So we would normally now work out the probability of getting something at least as extreme as something we've observed, but in this first part of the question, we haven't observed a number of people and we've been asked for a critical region. So we think about how we normally set this up. Now we normally do the probability that X is at least as extreme as some observed number. So I'm going to have little x standing in for my observed number, and at least as extreme as, for this alternative hypothesis, is greater than or equal to. Now we would reject the null hypothesis if whatever probability we get is less than or equal to the significance level, which in this case is 5%. Okay, so I'm going to kind of cut out the middleman. I'm going to get rid of the equals of probability because we don't know what it is because we've just got some x's. So instead, we're just going to write straight away we want this probability to be less than or equal to 0.05. Okay, so if we can use our calculators to work out this value of x. Let's have a little sketch of what's going on. So here's some binomial values. Okay, now if we have the value of x, then we're going to reject the null hypothesis. So we know that this probability here would be less than 0.05. Okay, I could have any number that's greater than or equal to that value, but we're going to find that the smallest possible value of x so that we reject the null hypothesis. And we call that value of x the critical value because it's kind of the cutoff point. Okay, and we call this set of numbers, so it will be x can be any so anything bigger than or equal to x would be the critical region, because for any of those numbers of patients who have made substantial improvement, we would reject the null hypothesis. So this is the critical region, sometimes called the rejection region. Okay. However, if instead we got a number less than that, for all of these numbers, we would happily accept the null hypothesis. We'd say we can't reject it, so we accept it. So sometimes this is called the acceptance region. Okay, the crucial one is the critical region, but we have seen some questions with acceptance region. Okay, right, so we use the calculators to work out what this value of x is. So here we go. So I'm on binomial, I want to do greater than. I don't know what x is, so I'll just leave it at 5 at the minute. We've got 14 trials, and the chance of success is 0.7. And we go execute. I'm going to change the probability to be 0.05 because I want to find out what's x when my probability is less than or equal to 0.05. Okay, so it hasn't given me 0.05, but it's given me something close. So I'm going to write down the probability x is greater than or equal to 12 is 0.161. Okay, so I know that's too big. So what I can do, so I've got a number here that gives me a probability that's too big, so my number's going to be too small. Oops, that should say 12, really, shouldn't it, rather than... Let's see. Okay, so let's have a look at the calculator again. Let's change this to 13. Okay, and then we get a probability of less than 5%. So I'm just going to check its value. So 0.0475. So we've got the probability that x is greater than or equal to 13 is 0.0475, which is less than 5%. Now I have to write this working out down because this is proving that 12 isn't big enough, but 13 is big enough. Okay, so then my critical region would be any x value greater than or equal to 13. We would reject the null hypothesis if x is any number greater than or equal to 13. Okay, so let's look at part 2. We're now given that we've got 12 that have shown substantial improvement. So for part 2, to carry out the test, we just have got that 12 is not greater than or equal to 13. It's less than 13. So there's insufficient evidence to reject the null hypothesis. It's not in the critical region. Okay, so it is unlikely that, and then we copy words from the question, so we go back up. The proportion who've shown substantial improvement is greater than 0.7. Right, so the last part of the question, what is the probability of incorrectly rejecting the null hypothesis? So all of our calculations have been based on assuming that the null hypothesis is correct. But we would reject that null hypothesis if x is in the critical region. So the probability of incorrectly rejecting that null hypothesis is going to be the probability that x is greater than or equal to 13, because that's the critical region. So that means that here we've got our answer to part 3. Okay, so there's a 4.75% chance of incorrectly rejecting the null hypothesis.